started is just determine, are they like terms? So with your group or yourselves, just do this column. Tell me, are these like terms? Yes or no? Remember what it means to be a like term. They have to have the same power. Same exact power. Hopefully that was pretty quick for you. Was number 1 this like terms? Yes. What about number 2? No, because 1's a 2 and 1's a 3. What about number 3? Yes. And what is 1/2? I keep trying to bring these back. What does half really mean? The square root. Thank you. Think, whenever you see 1/2, I want you to think square root. If you see 1/3, I want you to think the cube root. Okay, that's really what it means. What about number 4? You sure?
Oh, yeah.
You're right. Just kidding. I was just double checking. They have to be exactly like terms. They have to be exactly the same in the power. Okay? Questions on that? All right. So now let's actually start doing it. So we have the sum. Well, that's pretty easy. What is 5x to the 4th plus a negative 9x to the 4th? Yeah, negative 4x to the 4th. Okay, you guys find the difference. You guys find the difference. It's hot here. Okay, you should have got 5x to the 4th minus a negative, which then changes it all to positive. So negative, negative, make a positive. 9x to the 4th, which gets you what? Very good. Cool. If they are not like terms, it's pretty straightforward because you can't combine them. So we would just rewrite it out. I would just have x squared plus x cubed. I can't do anything. I could just write it like this. Same thing with the difference. I can't add or subtract anything, so I'm just going to rewrite it out. Okay. This one, remember, they are like terms, so we have 8x to the 1/2 plus 2x to the 1/2. Again, they're like terms because these are exactly the same in the power. What would be my sum here? Yeah. 10x to the 1/2. You're not changing that variable at all when you're combining like terms. All right, do the difference. You should have got 6x to the 1/2, hopefully, when you were working on that. Do you have any questions on that? Okay, there is a rule when we're doing these. You have to have, we haven't even do the next one. Okay, for this one. Yeah, we're just going to be rewriting it. 5x to the 2/3 plus x to the 1/3. Because I can't do anything. That's a half, not a 3. And then same thing here. You can't do anything with these because they're not like terms. And like I was saying before I realized I didn't do anything on that last one, that there is a rule when you're doing these. The radicals have to be the same. Make sure that the index is the same when you're working with radicals. So like square root, the index is 2. Cube root, the index is 3. Fourth root, the index is 4. It has to be exactly the same. If it's not, then you can't combine them. So radicals need to have the same index and what we call the radicand. Radicand. Okay, remember what the radicand is. Inside. Okay, so like the square root of 3. In order to add and subtract, you also have the square root of 3. You can't have like the square root of 4. They're different. Completely different. Right? Questions? Okay, so now let's do a couple together. It says 4 cube root of x, and the more that you say it out loud or say it in your head, the better you're gonna be able to do these problems, because a lot of people are like, oh, it's 4 square root cube x. Like, it doesn't make sense. Make sure you're able to say these when you're doing them. So, are they like terms? Do I have exactly the cube root of x and exactly the cube root of x? Yes. Okay, everything's the same. Remember, if you forgot, I'm just going to kind of give you a little side note here. If you forgot, these are your index. These little 3s, they are your index. And this was your radicand, if you were confused on what I was talking about earlier. The x's are your radicand. So now what's nice is that we can just go ahead and add them. So when I add them, I'm just going to rewrite it out for you. It's pretty straightforward, because all you're doing, if you have a highlighter, all you're doing is you're adding those front numbers. So what is 7 plus 4? Yeah, 11 cube root x. Okay, do the difference, please. When you're done, and when you're done, only look up. Do you have questions on how I got negative 3 cube root x? Yes.
What is the negative?
Good question, because when you take the difference, you're going 4 minus 7. Yeah, you gotta stay in the same order. That's what it is. Yeah, so if you're wondering why it's negative, because you have to say, it says, what is the difference between 4 and 7? That means 4 minus 7, which is negative 3. Okay, are these like terms for number 2? No, they are not. So I'm put no. And I'm not going to rewrite these ones. I just feel like it's pointless to rewrite them, because we would just be putting an adding and a subtracting sign. So I'm just not going to do that for you guys. If you want to, I'll just do one so that you understand. I just have to rewrite it. I can't do anything, but I'm not going to waste your time. And here's the reason why. So if you use a highlighter, this is a square and this is a cube. Square root, cube root. That's the reason why you can't do this. What about the second one? No, why? Yeah, the radicands are different. This is x and this is y. Okay? What about this last one here?
Yes.
It's not the last one actually, but yes, they are. Why are they?
Because technically it has an exponent of 1 and there are no.
Well, it looks like when you originally look at this that they're different. But can we break down 18?
Yes.
Yes. What can I break 18 down into? Yeah, 2 and 9. And now do you see how we're going to end up with the same radicand? Okay, so then I have 5 times 3, radical 2, which then becomes 15 radical 2 now. And that's why we can now add them and subtract them. So now it's yes, because you always have to look and see if we can simplify it, what we've learned yesterday, to add and subtract them. So when I add and subtract them, what is 15 radical 2? 15 radical 2 plus 4 radical 2. Yeah, 19 radical 2. Do the difference. Again, because we're just adding these numbers out in front. What did you get for this one?
11.
Yeah, 11 radical 2. Good job. Okay, so this next one here. At first, let's just see. We always have to check if we can simplify it to make them like terms. So we have, the best part is, okay, if these indexes are different, you might as well just say no. Okay, but these are the same, so you have to check and see if you can simplify it. That's kind of my trick for you. Okay, if the index is different, there's no way that you're going to be able to combine them. But this case, it is. So, how many times does 3 go into 4? 1 time. So that's why I put x to the first power on the outside. Cube root, and how many's left over after I take 3 out? 1. Now they're the same. Okay, there's an x here. Should I have an x here? And then I have an x inside the radicand. So when I add them, I'm going to write this one out. I have x cube root x plus 6x cube root x. I'm going to take my highlighter and show you that we're just adding those numbers out in front. What is x plus 6x? There we go. Do the difference, please. Not so bad, right? What did you get when we did the difference? Negative 5x cube root x. Here's why. I'm going to write this one out just to make sure that you guys understand why. It's x cube root x minus 6x cube root x. Okay? You have to write it in that order. If I say the difference, you have to do it in the same order. You can't switch it up. Okay? All right. So I want you guys to read this with your group. Or read it and then talk with it with your group. And see if you can tell me who's correct. On the bottom here. You got Larry and you got DJ. Larry and DJ discuss whether or not 4x and negative 5x to the 1/2 are like terms, given that all the numbers are positive. Who is right? So see if you guys can figure that out as your group. Take a minute. Some good conversations right now. Okay, DJ is our winner here. And let me explain why. How he's correct? Yeah, so DJ is correct, and here's why. Because I know I've said this, and Ms. Markowitz has said this a million times. What does this 1/2 really mean? The square root. So technically I have 4 square root x and negative 5 square root x. Now do you see that they're the same? Yes. Okay, so now they're exactly the same because I have the same index. Does it make sense now? Yeah. Okay. Remember, you have to know that. You have to be able to go back and forth between exponential form and radical form. Okay, flip when you're ready. There you go. All right, so let's have some fun here. This is fun for me. Okay. You first, no it's not. You first have to see, do I have to simplify anything or are they going to be like terms already? Do I have like terms? Yes, so all I'm doing is I'm adding those numbers out in front. What do I get when I when I subtract 18 minus 11? Good. You're done. Look how easy that was. Okay, let's look at this next one. Do I have all of the variables the same? Do I have all of the indexes and radicands the same? Yes, so all I'm doing is I'm adding those numbers out in front, which gets me b to the, very good, b to the 2/3. Okay. Now again, if this little guy right here was a 5, no. Okay, nothing can be different in that terms there. Okay, so let's look at this next one. They don't look the same. So we know that. And we can be like, oh, but they're both square roots. Maybe they can be the same. We have to figure that out. You never know. Maybe we do it and they're not the same still, and that's okay. But you have to check it. So let's do it one by one. Take it piece by piece. So the square root of 27 breaks up into what two numbers? Good, and the square root of 3. So I'm going to go ahead and I'm going to bring out that 3 because the square root of 9 is 3. So I have 2 times 3 times x so far on the outside. How many times does our little index 2 go into 3? Once. So I have another x here. And how many's left inside? 1. Okay, how do you do that again? How many times does it go in there? Well, 2 goes in there 1 time. So I have 2 x's that I circled. Well, I still have one left over to get 3. So now I'm there. Now I'm just going to go to the next one. Take it piece by piece. What two numbers break up into 48? Yeah, 16 and 3. So I have the square root of 16 times the square root of 3. 3. Yeah, thank you. See, guys, that's why I have you. I forgot my 3. See, this guy? Forgot him. I need support sometimes. It's too early in the morning. All right, so we're going to go ahead and we're going to bring that 4 on the outside because we know the square root of 16 is 4. Bless you. How many times does 2 go into 5? 2 times, right? Because 2 times 2 is 4. So I'm going to put x squared on the outside. But how many is left over? 1. And I still have that 3. So this guy is left, this guy is left. That's why I'm going to make sure that we write that out. Because I almost forgot last time. Now I'm just going to simplify. 2 times 3 is, and x times x is. Good. And then I'm just going to write all of this out. Now are they exactly the same? Are you sure? Yeah, I have an x squared, and I have a square root of 3x on both of them. Now we can actually do some math. We can now combine them. And I'm going to highlight what I'm combining. 6 minus 12, what do I get? Negative 6. Please make sure your signs are still there. Everything else just comes along with it. That's it. It's hard. I'm not saying it's easy, but you got it. You can't just learn right away like that. I mean, some people can, but I can't. Okay, let's keep going. Actually, no, I want you to do the next one. I want you to do D. D is nice because there's like no letters or anything. Yeah. Try breaking it down what we did yesterday. Can you break down 12? Can you break down 27? Now is a great time to ask. When you're done, and when you're done, only look up. It won't benefit you if you're not done. It's okay. Sometimes it's just really early in the morning. Check your answers. Yes. Good question. Listen. The question was, how did I get 18? Because sometimes I don't write everything out because I know that no matter what happens, I have to multiply the outsides. The square root of 4 is 2 times 9 is 18. That's how I got that. The square root of 3, the square root of 9 is 3 times 13 is 39. Okay? Again, maybe you just got that first step and you didn't get to the second step. That's okay, you're making progress. You have to give yourself some wiggle room. You're not going to learn it right away. Math is not easy. Okay, let's go ahead and do the next one. Okay, we have the same index, so we know we might have a chance here. So let's start breaking it down. Perfect cubes. Do we know a perfect cube that goes into 32? 8. Very good. Now, if you are someone that did not know that, it's okay. Just go ahead and break down and do your factor tree. That's fine. Okay, so then the cube root of 8 is what? 2. So I'm going to bring that on the outside, give myself some room in case I need to write some variables. And that 4, maybe you should underline that to help you, is going to stay inside. Sometimes I like to underline things that are going to stay inside the radical. How many times does this index of 3 go into 5? Only one time. I can only pull out one group. Now think. What's 1 times 3? 3. And I need 5, so how many's left inside? 2. Very good. It's okay. Question on that. Okay, let's go ahead and do it again. So 108. Now this is something in my brain. I'm like, I don't know the perfect cube that goes into 108. Maybe you guys do because you have a calculator. I don't. Okay. But we can break it down. What do you want to break it down into? 54? 54 times 2? Is it? Okay. Okay. My brain is not working today. Okay, so then we got to keep going. Is it?
Yeah.
It's a perfect cube? What? My brain is not working.
No, it's 1.7.
Yeah, I was like, that's not a perfect cube, silly. Okay, so now I'm there, and I'm going to break this down. What two numbers break down to 54? What'd you say? 27 and 2. Do I have a perfect cube yet? I do. The moment you have a perfect cube, you might just want to stop. If you recognize the perfect cube, you can stop. I know that the cube root of 27 is 3. I know that. You could just stop right there. I mean, you can keep going. But if you notice that, why put more work on there for yourself? So I know that 3 is going to go on the outside. So plus 3, and that x is out here. What is left? What number is left inside the radical here? 4. Good, because look at what I underlined. 2 times 2 is 4. Now, how many times does 3 go into 2? None. I can't take anything out of my x's, so the x squared is going to stay inside. And now look, we have everything we need, and we can go ahead and just add them. What is 2x plus 3x? Yeah, 5x. So the hardest part, in my opinion, is just being able to break down the radical. Because everything else stays the same. Okay? Now, F looks challenging, but I promise you, all you have to do is break down the radicals, and you'll be okay. Peace. I did one step up here so you can just see your progress. If you're still working on it, at least did you get this far? Okay? Because if you notice, it actually wasn't that hard because this guy didn't do anything. So check your answers. Now, if you get to like this step and they're not all the same, I would just go back and make sure. Because sometimes I really don't feel like we're going to be tricking you like that, but maybe. But majority of the time, it should be able to add or subtract. Not all the time, obviously, but when we're giving you stuff, we try not to trick you in any way like that. Okay, now this actually is pretty easy now that they're all the same, because what's 12x minus 2x plus 8x? Yeah, 18x, then don't forget to attach that 2x on the side. Do you have questions or want me to explain any piece of this problem? Are you sure? All right, so let me think here. I just want to do H, and then I can give you your homework because I feel like you're doing okay. Because you've already done a cube root one, right? We've already done a cube root. Yes, we did a little bit. Let's do H. Let's do a 4th root. Okay, remember, just because there's a 4 in there does not mean we can't do it. You now have to circle groups of 4. Okay, there's no 4th root of 5. How many times does 4 go into 7? One time. So I'm going to go ahead and write that out. 10, and I have once. One time it goes in there. That means I have a total of 4 y's. How many do I have left inside? 3. Very good. So 5y cubed. Do you have questions on that part? Because some people get confused on what I mean by how many is left over. Okay. Now we can break down this 80. I like to use tens because I know that that's pretty easy when you have a 0 at the end. Okay, again, me personally, if you don't know, keep going. 5 times 2, 4 times 2, and 2 times 2. Okay, that's gone. We use that, we use that, we use that. Ooh, why is everything moving on me? Give me a second. When I do this, if you're someone that's really organized or gets confused by things, my tip for you, if you were to do the tree, the moment you break down a number, cross it out. Because I've seen so many times on the test where you include that 4, but you broke it down. You can't include it anymore. So if you're someone that likes the factor tree, I highly recommend doing that so that you don't get confused. Now, if you take a look, I do have a group of 4, and it's the 2s. So sorry, I'm going to have to rewrite this out. Down here. Okay, 10y, 4th root, 5y cubed. Okay, I'm going to bring out a 2. How many times does 4 go into 3? None. So I can't pull anything out. So just bring that y down. 5y cubed. And why I got 5 is because this guy is still hanging out right here. That's why that 5's in there. Now we can go ahead and add them or subtract them in this case, and what do you get? Very good. How do you say this? Keep going. See, it's not cube root. Yeah, the 4th root of 5y cubed. And I'm gonna I want you to keep saying that. If I say the 4th root and you don't